Welcome to Quality Branding Hub. The channel is for the quality control engineer, site engineer, and the civil engineer who are working in the construction field. In this channel, we are dealing with anything and everything which is required to get success in the constructions. Today also I'm going to discuss about a very important topic for the quality control, that is root cause analysis. The every civil engineer or every quality engineer who are working in the site, they need to perform the root cause analysis to find out the what is the main reason of the defects, to eliminate the defects in the process. But what is root cause analysis, what are the component of root cause analysis, and how to perform a root cause analysis, I will discuss each and everything in today's video. So stay tuned until the end to get the full information about the root cause analysis. So let's jump into the subject. And if you are new on my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notifications. So without wasting time, let's jump into the subject. That is today's topics, root cause analysis, or sometimes it's called RCA in abbreviation form. So what is the definition of root cause analysis that we need to know first? Root cause analysis or the RCA is a systematic process used to identify the underlying reason for a problem or defect. Now, we need to find out what is the exact reason or what is the underlying reason for the defect or the problem. Say for example, if you have any problem in your health, you want to go to doctor, and after consultation of doctor has given some test. Why he has given some test? Because he want to know what is the main reason of your problem, and after coming the test report, he can analyze the test report and find out the solution of the problem and give the solution or the medicine. The same way, whenever we are doing in a projects, it is obvious that the problem or defects will come. Whatever the process we are making, maybe it is 100% correct, whatever, but during the process or during the construction, it is possible to come the defects. Now, we as a quality control engineer, it is our duty to find out why this process has the defects. So that underlying reason we need to find out, and we need to redefine the process, or we need to give the solution or the corrective action and the preventive action. So that is root cause analysis, a systematic process to identify the underlying reasons for a problem or defect rather than just adjusting its symptoms. So suppose you have a fever. Now you're only taking the paracetamol to reduce the fever, but it is only adjusting the symptoms. But what is the main reason for the fever? That you need to know, that you need to do the root cause analysis, or you need to do some test. The same way, here also we will not addressing the symptoms, we will find out the underlying reason, and we will attack and or will redefine the process to eliminate the defect from the process itself. The goal is to eliminate the root cause and prevent the reoccurrence of the problem. Now, why we need to do the root cause analysis? If suppose we are getting any defects, or we get getting some cracks in the concrete, we can find out some crack repair material, and easily we can make the crack repair. But why you need to do the root cause analysis? Why you need to find out why this crack is generating? Because if we only appear or only repair the cracks, the same cracks will generate in other areas also, because we are not identifying the reason and we are not introducing the remedial measure in the process itself. So it will not helpful. So why root cause analysis help enhancing quality, that we need to know. So first, it is prevent reoccurrence. That is already discussed, that crack can generate in one places, but if we are not doing the root cause analysis, or we are not find out the root cause, then these will again generate in other places also. So this root cause analysis helps to identifying the root cause and ensures the same problem does not occur again, thus improving project reliability and the quality. Then improve process. Now why? Because whenever the defect is there, that means there is something flaws in the process. Now whenever we are finding out the root cause, then we can do the remedial measures in the process. Then this process will redefine. Now this redefined process will not eliminating this error, and then there will be cracks will not generate, as just for an example. So RCA identifies weakness in process, allowing for optimizations and better quality outcomes. So that is why RCA also improves the processes. Then reduces cost. Why? Eliminating recurring issues save resources, time and money, contributing to the project efficiency. Not only it saves the money and time and reducing the waste, it is also helps to gain the confidence to the customer, so the business will grow. Then it is promotes accountability, encourage a culture of continuous improvement and responsible problem solving. So it is encouraging a improvement things, the cultural improvement, that is continuous improvement, that is PDCA cycle. So it helps us to promote accountability also. So this way, the root cause analysis helps in enhancing quality. Now, what is the steps to perform a root cause analysis? Of course, how we will perform the root cause analysis whenever any defect is arising. Now, the first steps is that define the problems. Why? First, if you cannot define the problem, you cannot access the root cause, or you cannot find out the root cause and find out the solution. So first you need to define the problem, clearly identify and document the problem. So not only identifying, you need to document the problem. Maybe the crack is there, what is the crack width, what is the crack location, what is the crack length, what is the crack depth, everything that you need to document it. Be specific about what occurred, where, when, and under what circumstances. That means when it is happening, where it is happening. Every minute details is matter in the quality control. That is why whenever you are doing the root cause analysis, that every details to be in the identifying the problem section. Then what is the example we can take from the construction? That cracks appeared in freshly poured concrete slabs after curing. So these are the identification. Along with that, what is the cracks nature? What is it? Either it is a hairline cracks, or it is a deep crack, wide crack, and what is the crack length, and what is the crack location? That's in the beam column junction, or the middle of the slab, or in the L/3. So that exact location also need to be mentioned in the problem. So first thing is that define the problem. Then collect data. Now you need to collect data, because without a data it is impossible to find out a solution. Because if there is no data, then it will be an opinion. So without so opinion can be accepted, but it will not help you to find out the root cause to give the proper solution. So first thing, define the problem, then collect data, gather evidence such as photos, reports, environmental conditions, that is whether it's a windy or rainy, or there is any other condition that you need to find out. Then add interviews with the workers, so whoever worker on that, how they perform and whatever their efficiency level, that you need to understand to find out the root cause. That why you need to do the interview also with the workers to fully understand the problem. So what example we can take? That inspect the cracks, review the concrete mix design, check weather condition during pouring, and interview with the team responsible. Not only the team who are making the concrete, who are transporting the concrete, who are pouring the concrete, who are doing the curing. So these are all you need to find out, or these are all you need to gather data to find out what is the exact problem. So we have defined the problem, then we have collect the data. Now identify possible causes. Now how we can do? We have the data. Brainstorm all possible reasons that could have contributed to the problem. Use tools like 5 whys or Fishbone diagram or the issue diagram. So these are the tools you can use the data, and with the help of that tools you can easily find out what is the root cause. So I have made a detailed video about the Fishbone diagram or the Ishikawa diagram, how to find out a root cause and how to find out a solution. Please check a link in the below so that you can get how to analyze the data and find out the root cause. So identify possible causes, then Example which we can take from the construction, possible cause might include improper mix ratios, inadequate curing, or extreme temperatures. So it can maybe, suppose you have taken all the data, you find the mix design is proper, your environment condition is proper, but you find out that there is a flaws in the curing process, or the worker who are doing the curing, they are not well educated or not well trained. That is why there is a deficiency in the curing, and that is the reason this crack is generating. So now you are finding out that cracks is generating on because of the improper curing method. Now analyzes the cause. Examine the identify cause and determine the primary or root cause. This often involves testing and validating hypotheses about what led to the issues. Now you have find out what example you can take. Testing reveals that the water cement ratio exceeded the recommendation limit, causing shrinkage cracks. That also may be a reason. Okay, so one reason we can find out that is a improper curing. Now we can find out the water cement exceed the recommended limit, that also generate the cracks. Now you have find out the root cause. Say taken one example that the curing method is not proper, curing was inadequate, that is why the cracks is generated. So you have identified the cause. Now you need to develop the solution, because already I have find out what is the root cause. Now create and evaluate corrective action to address the root cause and prevent reoccurrence. This solution must be practical and sustainable, because this should be practical, impractical not solution, and that should be sustainable. Why sustainable? Whatever the solution you are taking, that should not affect or that should not harm the environment, it should be environment friendly. Now whatever the solution we can take, so for the example, we can find out that the crack is the problem for the improper curing. Now we need to do the proper training to the worker, we need to more vigilance for the curing monitoring process, and we need to do the maybe the protocol, the signing for the site engineer, quality engineer, and the higher authority also, to monitor the progress or the curing. Or we can do some drone shoot, or we can take the videos, or we can take the photos in time to time to monitor the curing is in the process. So this solution to be implemented. Now implement and monitor solution. Now you have get the solution, now you have to monitor. Introduce a checklist system that the curing is in the process or curing is adequate, that you need to do the as per the requirement. So you need to implement this solution into the process. Now the process is become redefined and you have already identified. Now if this process is identified, if this process is redefined and the curing monitoring process is implemented in proper, then the crack will not generate, we are assuring. So these are the 6 steps, and then document and communicate. Now this 7th step also very important, because you have done everything but it is not communicated, it is not documented, then there is no point or there is no use. So what you need to do, record the entire process, finding and solution and quality document, share this knowledge with the team to avoid similar issues in the future, and prepare a quality control report and use it as a training tool for future projects or future. So whatever the drawback, whatever the lesson learned you from this incident, you need to prepare a quality report, and from whenever you are doing next quality meeting or quality training, you need to do the training through the worker also. So these are the simple 7 steps you need to follow to do the root cause analysis. That is, define the problem, collect data, identifying possible causes, analyze the cause, develop solution, and implement and monitor solution, and document and communicate. So these are the things about the root cause analysis. This is a quality control tools widely used throughout the world to find out the root cause and find out the underlying defect, and it redefine the process. So these are all about this, and I hope you find it useful. And if you find it useful, kindly subscribe my channel and hit the bell icon, so that whenever I upload a new video, you will get immediate notification. So without wasting time, I'm waiting for your valuable comments, so that from your valuable comment everybody will be benefited. And if you want to know anything more about quality control and construction, please let me know, I will come with more content like this. And thank you once again for watching me.